So to do it, we need a few steps. Define extension point, which is simple. Basically, have register that org JBoss AS controller extension in meta-inf services, and put the name of your class that implements service. Define the root model. This is what the root model of in the management tree will look like for that extension. Define one add handler, so the server knows what to do when the add is called. Define XML parser and marshal. And this is basically it. This is the whole interface that you need to implement. It's just, does everyone see this? Okay, cool. Have a class, implement extension has two methods. One is initialize parser. This is the part that I told you earlier. When the extension is registered, this is the method it's called. You register any parsers you want, so the server later on knows where to delegate the stuff. And then when the proper initialization is done, your initialization block is called. And it's really simple when you look at it that way, but it gets harder then later. That's a service loader entry. I think that is quite self-explanatory. This is a bit harder then. This is the resource, the root resource. Basically, you need to provide the resource definition, the instance of resource definition. We have many implementations and handlers to help you write that. Resource definition is basically some interface, I think, right? Yeah. That requires you to have some attributes and operations, and so there are a few callbacks methods that are called there. So you have to register all of your stuff there. What we did later on, we added some friendly APIs. This is the latest iteration, just available in WildFly 8. Before that, it was a bit harder. And Kabir is learning about that just now. It's a persistent resource definition that basically allows you to write the whole resource without caring about parser. The parser is generated for you, or basically it's runtime-based parser. What you do is register, you tell them what is the path, where should that be registered. This is the subsystem that is called a path element, which is basically key value thing. In this case, this is how I show that it's just subsystem and the value is SDD in our case. SDD stands for Silly Deployment Detectable, which we'll take a little bit later. Here you provide them a resolver. The resolver is a class mechanism that allows us to provide proper descriptions for all the attributes. Basically, we have defined the attributes, but we want to have like some nice capability to have them translated or not. Our default implementation there is that what it does is take a look in the one properties file, and where you have key value, the name of the attribute, and the description of it.
Sorry, quick question.
Sure.
So this is just the loading of the DTD into this thing called a model, effectively?
Yeah, basically you're defining the model here.
Yeah. Okay.
You're basically saying that this resource definition is the definition of the resource that is registered under this path.
Yeah, okay.
That is basically what it does. This is what you do here, defining a resolver to tell how these properties of this resource should be resolved.
Yeah.
And then later this is the compact version, everything in one line basically. There are other options to do that.
Awesome.
Basically here what you do is register the add handler. What should be done when this resource, because it's a resource definition, basically you should imagine that like you have a class and you have an object. The object is an instance of class.
Yeah.
In this case, resource definition and the resource is the instance of this resource definition registered under this path.
Okay.
You know, everything is dynamic, so it has to have a bit more metadata to all that work. The other thing you have to do is basically do this, just this part here. And this is only important for the root resource. And we optimize also that this some generic stuff, you just register it, it's already done, you just have to register. Basically what that thing does is enables you to define the whole resource, when you do like root resource definition, it's, this is the describe thing we need it for the domain nodes. to describe the whole resource to the end user or the system. And mostly when it comes to domain mode, we need that described information to replicate that model to the other servers. So in the first instances of AS7, this thing was a bit more complex. You had to write a really spaghetti code to define what this model is. Basically, you were defining the DMR by hand, which is really not user-friendly. I won't show you the code because you would get scared. Basically, what the stuff we did later on just generates most of that stuff. In some cases, you still have to override that because we have some special cases, but I think we have like one or two. The data source.
JCA has something.
JCA has one, and I think that the J groups is another one, yeah. But basically, everything else is using this, and this is just for the root resource. For all the other, you don't need to do that second part. You can use that. Okay, this is the callback operation, the method that is called when the method operations are getting registered. You could do here any other operation you want to have. The add is just the default and the remove other stuff, like whatever you want. Basically what it does is just register operation handler with this definition. The definition tells what parameters it has and what is the response type, and this is the handler for it. And this false at the end tells is it inherited or not. It should be replicated to the lower levels of the resource or not. In our case, we don't need that. And this is the add handler. It's really complex, the default one, because it doesn't require any attributes to be set. It's like just empty thing, and I even think that this is not required anymore. It's also back in our testing framework to require that. Try and fix that like a week ago.
It hasn't been needed for a while.
Yeah. What?
It hasn't been needed for a while.
I don't know, we can talk later. There's so many things in my head, so. And when you have to maintain EAP branches and WildFly and different code bases, you get kind of confused. What is where and where it's not. So basically, this is just for the namespace. Why it is a num and so on is if you want to do more than one version of the XCD. Basically, most of you saw when the new version of WildFly AS7 came out, there was like subsystem, and there was like JCA 1.0, and there was 1.1, 1.3, or so on and so on. And this way you can register different versions of the XCD, and what we do is we support all the old versions of the XML configuration we had, unless they were really broken beyond fixable way or mappable to new one. But I think I'd safe to say that we are from 7.1.0 and up to now there are like many versions. The EAP versions count. And you can do any configuration, you just copy the configuration file over to WildFly now and it should work. Okay. With WildFly you have to remove the web subsystem because it's not there, and basically it's under top. But basically everything else will be upgraded for you on the first start. So that's why you have to register more. But that's it. For instance, we have few subsystems that is the only configuration they require. You probably, what is one of them? Weld used to be like that, now they changed it. JMax, I think. They're like, you need to not define anything, just tell them, I want to install this extension, that's about it. Then you have to define parser. So here that is what you want to hear. It's basically, we have some builder API that just give them the root resource and tell them, okay, great, generate parser for it. We had some, this is needed so we can have different version of parsers and we can generate them. In our case, this is a simple, I'll show a bit more complex one a bit later. And when you're reading, you just say this description parses for me and it will do everything for you. And this even works for much more complex examples, not just this. For instance, the whole undertow subsystem is written like that. But the parser is not one line, but a bit longer. And when you're doing the marshal, or like persisting back the XML, this is everything you have to do. So basically, what does this subsystem we did now do?
configures itself, allows itself to be configured.
Exactly. It doesn't do anything else beyond that. Nothing. It doesn't even log a message. So basically, this is what we do just on the extension class implementation. Just register the parser and register the root resource and register the write parser. Because the write is always one, because you always serialize the current version of configuration, but you can read many different versions of configuration. So this one is separate, the parsers are different. That's the whole subsystem. Oh, okay. I added also this. Yeah.
Does it mean if I have an old version,
Yeah.
I let WildFly to load it, and then if I make a change in runtime or by CLI, whatever,
Yeah.
the new version saved will
Yeah.
contain the new version of
Yes,
the
of course.
So it will like auto-convert it?
Yeah, the thing, what happens is basically the parser reads the old configuration
Yeah,
and generates the DMR operations for the running model.
indeed.
And then the running model is marshaled back.
Using the latest only because there are no
There are no other versions of the model. Model is always one.
Okay.
And the marshaller will always just pick what is there and save it with what he knows is the latest version. And the thing is that when we are changing the model all the time, the old parsers cannot catch up in many cases, and basically we fix the old parsers to work with the new stuff. That is the real work where it's happening. The new parser, we add the new parser to parse all the new stuff, and then we modify the old parsers to check all that. We have quite extensive testing framework for all that stuff. In some cases we miss something because our tests are not really perfect, especially with the big subsystems where they're like different types of configuration, there where it's like if-else, if this is defined then you have to have this and so on and so on. In that case, sometimes we cannot really test everything, but we really try. So it should be working. So basically, this is then the last part. How you define the model, just your jar with all that. These are the dependencies you basically need. Not all are needed, but I just took one example somewhere else. What you need is basically the XML parser, the controller, and that's about it for start. But this is from a bigger example, so I'll show it.
Is there any good way to work out what those dependencies are, other than to just keep starting it up and finding the ones you're missing, which is my current approach?
Not really.
Not really.
There is a project called, I can't remember.
By Jasper, that'll tell, yeah.
Well, I haven't used it, so.
Okay.
But apparently that's meant to be able to at least sort of inspect jars and find classes needed from another one, but I'm not sure.
That's one.
Standard approach will continue.
Yeah, that's a standard approach. What you can do, what I sometimes use is, you can just take Maven and ask Maven to find you unused dependencies. But the problem is that some dependencies are runtime only and are not compile time, so it's really, really tricky in many cases. So try and fail, that's actually the big problem. What we added in JBoss modules 1.2, I think, is really cool stuff if you want to know, is you can ask him to drive you, to tell you what is the dependency tree of one module. You give in your entry module name and say it's basically Java minus jar, JBoss modules minus the jar, and minus dep tree, and entry point module. You can say, in this case, you could just say, give me the WildFly extension as a DE, and it will list you all the dependencies transitive that can be affected and how they go through. It's a useful thing. I was using that when I was flipping the core distribution, so I can see what is used where and how. So we figured out that it doesn't do nothing. Then to do all that is we need to test to make sure that everything works, the XML parser works, that the model is consistent, that the services are properly done and started and so on. And yeah, we need to test compatibility in many cases and localization of resources and test that everything's done. This part here, most of you will never know about, but most of us really, really work hard to make it work. This is basically when you have domain mode, and you have host controller, a domain controller, and many host controllers, and you want to do upgrade to the newer version, and you cannot afford to upgrade all the servers at once, and you want to do a rolling update. So the requirement we did is you have to upgrade the domain controller first, and the domain controller, even if it's a new version, is able to manage the old version of host controllers. So you can do slow updates, like one machine and another machine and so on, and still everything will work. And to make all that work is the versioning of the resources and the subsystems and so on, how the stuff is done. One thing I didn't really point out earlier is the thing here, you see, when you're registering the subsystem, you register it under name and the version. And in most cases, if you're doing something for yourself, you'll have one version. In our case, every time we release a version that is publicly released version, that version of the model is final for us. So any change that is done, even if you do add just one attribute to one resource somewhere in the whole chain, the version is bumped and it will be 1.1. The major versions is registered for bigger changes. And so on and so on. And this is what we need to require and say, okay, the host controller is for version 1.0, but the latest version is 1.1. The model is not compatible. What to do now to make it work? This is where the transformers I talked about come to play. That is a special part of code, quite complex. It basically defines the rules how resources can be transformed. If there is something that can be ignored, just transform it. If that is an attribute that is not defined, in this case, it's okay. We can just say, okay, just do that, but remove this attribute for the result. It's undefined. But in many cases, what we have to do is just say, man, sorry, you cannot apply this profile to that host controller because there's an attribute you're using, and we don't know if you actually meant to use that attribute in that configuration there. But one attribute is usually just small. There are sub-resources and really big parts of configuration. So it's okay, if you don't have that part configured, we can move that, we don't mind. But if there is something configured that is different, sorry, we'll let you know.
For example, turning on something that only exists in the new version, then this is not possible on the old one, so you have to reject it and say you can't use this.
So basically what you do then is have the domain mode allows you to have multiple profiles of configuration, and you can say like for legacy. And you have just stuff that works on the old version of the host controllers, and then you apply that configuration to that until you upgrade them, and then you can just push the mainline, all the new features and so on there. So this is there. It's a whole big chapter. We won't go there. It's basically really boring, but important for big deployments. Okay, and to do testing, we have a really nice framework that Kabir wrote, and it's a big, extensive one. And basically boils down to this: you just extend the extra system-based test in the constructor. You just tell them which subsystem and the extension you have. You'll be testing, and then you just tell them which is the XML you will be testing. And based on that, it will actually start the whole server, the register service call, add methods and everything, based on what in that XML is in that XML. So it's really important how we test it. But this simple test, as simple as it looks, can point out so many problems. Like if the XML is proper, for instance, you loaded, we read the version 1.0 of XML, which is that big, and then we call that, put it in the model, and write it back. It's different. Hey man, you did something wrong, and so on. But these kind of problems we solve with just helping and better tools. So let's talk about silly deployment detector. That was the name that one guy on the community said it would be really nice to have, and I did it, so here it is. It's still not done. It's ever welcome to pitch in because I don't have time to work on it. But basically it's the idea to have a subsystem that will just detect the common problems that you have in deployments. The common problems can range to as simple things as like wrongly configured to Maven and what dependencies are provided and what not. or just including all transitive dependencies into var, and stuff starts exploding because you have CDI jars. We implemented the whole world is there. It's like, come on, man. So let's have something to help with that. And it's really simple to write, actually. This is the idea. I'll show today just this one, the blacklisted jars. Because it was the simplest to do. I wanted to show the package name based one, but I ran out of time. We need to do the release, sorry. That was more important, I think. Basically, we'll do the deployment detector will just tell us, we'll have a configuration that tells all the jars, like patterns that we know that are bad, and the deployment detector will just warn us about it, nothing else for now. We could fail the deployment. For instance, what I want to do is, this could be really useful to have like as a development support tool as part of WildFly, because we have people complaining before, say I have issues because I don't know, and I'm bundling RTjar, the whole JDK, as part of my deployment. It's like, no, and you know, the deployment detector will just say, okay, you have Java lang package in this jar, we won't deploy that, sorry, remove it. Or disable the subsystem, we don't care, but just let you know. So this is what we'll do. We'll need to define the model, parser to handle it, and write the deployment processor. Oh yeah, and register it before that. This is a bit more, don't get scared, it's not that scary. Basically, you again do the resource definition as we talked. Then you define attributes, jar names. What are the jars that we are interested? And just define what is the XML name for it, do we allow moves, and so on. The stuff here is really basically the boilerplate. At what path we register it, what is the resolver to help us resolve that. Add handler, this one is the interested one. And remove one. Okay, this is the default remove handler, which actually what it does is when you remove the resource, just puts the whole server in a reload required. That means that you have to basically restart the server, just reload the whole configuration. This is a bad practice, to be fair. You want to do like as much as possible at runtime operation. Just remove the model, just remove that and so on. But we're doing the simple cases. So. And later, you can here you register the attributes. Just do the read-write attributes, so you can do write, like a column write attribute, name, jars, and find them. And this is a handler how to write it. It's really quite simple. Then the XML. It's a bit more complex now. We have one sub layer. And then we need to do the deployment processor. And I'll show you the code now, the proper code, because I think I had enough of presentation. And you should probably agree with me now. Okay. I won't be using WildFly final. I will be using the yesterday snapshot, which is basically the same. Just a piece of warning, so no one will blame me that I'm doing that on something that is totally different, what you can use just for reference, so you won't believe me. You see, it's from Monday, the code, so that's about it. This is the WildFly code. Okay, the subsystem now. What we have here, I'll blow it up a bit just to go here a bit. We did resource definition. Basically, this is a bit improved version of what I showed you there, but basically, let me. That should be better, right? The only difference what we have here is that we extend a different class that allows us to generate a parser for us, so it's not. You don't have to write a parser. The only difference is that you define the register attributes a bit differently. Okay. Then the important part, that interesting part is also here. This is the add handler. That what we want to do is register something when this is done. What this does is, I told you earlier that add handlers are split in different phases, and we are interested basically in two: model phase and runtime phase. In this case, this is the model phase, which is the method that we, in this case, we extend the abstract boot time step handler. This is just a special case because we want to add the deployment handlers. The deployment handlers can be only added to the boot time. Otherwise, it will just, the difference there will be abstract step handler instead of boot time, and here will be perform runtime. But everything else is the same. And in the model, what we do, populate model, we just validate and set as input we get the operation. This is the end operation, like address and what was done and the parameters, the part of that. And this is the model that will result in the model that is part of the resource. So what we do is basically all the friendly apps here to say validate and set. This is what validates the operation and sets the result of the model. And if you have many attributes, we basically just repeat that for every attribute that there is. Then in the runtime stuff, what we do is basically get back the blacklist, which is the list of strings in this case. That is just some handler stuff that helps us to get that from the model. Everyone sees that. It's there. Okay. And the next thing we do here is just register the deployment processor. What we do here is we define it. We say it's the name of the subsystem where it's registered. We register it in a phase parse because we want to know what's going on when we are parsing the whole deployment. And register it as a web deployment. When the web is done, web subsystem, web processing is done, its stuff, then we want to work on it. And we register our simple deployment processor. And that deployment processor is really, really complex. It has to implement deployment unit processor that has basically just two methods. One is called onDeploy, another on onDeploy. And what we do here is just get a deployment unit. This is some API to handle deployments. These are the internals now. And all the deployment units have many attachments because when all the chains go through, you can get attachments to different parts of the subsystem. The server just put and prepare the attachments there. So different deployment processor can use stuff that was prepared earlier. So not everyone is redoing everything. In our case, what we're going to do is just take all the resource routes. Resource routes is something that the var structure processor takes from the vars, and all the jars and lib are there. So, and we get a list of those, which are resource routes, basically the virtual files. We get the virtual files, and all we do then is just match if they match our blacklist. For every entry in blacklist, we match it if it matches. Really stupid, it's not optimized at all. And on the end, what we do is, if that matches, we just log it. This is a bit improved logging stuff we have. It's not just log.trace. As you see here, you can put like trace f into tracing. And we kind of have a rule that everything that is info and above logging, it has to be localizable, and we have like really strongly typed logging. This is it. This is the whole logging class. What we do is just have define what's the project code. So on the end you get like WildFly 001 is the error code. This is how we generate the error code. In this case, it's SDD because it's the name of the project. And we have one for subsystem started, one is for the jars, the IDs and so on. What we do later on is that this is just the interface, and we have the annotation processor, the compiler annotation processor. We generate the actual implementations of this. So it's everything done, compiled, done, and hidden from you. And now we should probably show you how this works, if it does at all. Oh, I'm running late. I'll be faster. Basically, what I have here is just a Maven project that helps me generate the module, the extension, install it in. You can just see what's happening. Here is the configuration we do, and this is the important part that we added just to the configuration. And I defined one module. Nothing really strange going on here.
Sorry, what's the plugin? Is that is that an internal plugin you use to build?
No, it's not. It's basically stripped down what we use for our build, just end stuff. It's end based. This is what we use in WildFly itself.
Yeah.
We need to improve how the modules are generated, and for now we don't have anything really better than that. We probably will tackle also that now that we're gonna move to development the WildFly core separately, and we can do bigger changes easier, because when you're part of the big code base like WildFly, you have to be careful about 500 modules, so many subsystems, so on, and you cannot even experiment with new stuff. So slowly, now we'll be able to do it faster. That doesn't mean it will be done in a month, but it's even possible to play with things like that. And now what I do is basically I have some script that says, okay, update the AS, given the path where my WildFly installation is. I compiled that now to Bianco WildFly 8 final, and it will work. It's no spooky thing there. I just install that. And it's done. And now this is small WildFly, it's the same folder. I'm not cheating or anything. So, and what I'll do, I'll just start it with the standalone SDD XML, which is a special configuration I did. And before I do this, I want to show you one more thing. Is that it's all clean, I'm not cheating. I have one deployment here, which I'll use to demonstrate this problem. This deployment, this is the lib, everyone sees that. Basically what you can see, it's really not that good. Okay, this will be probably better now. You can see this now? Yeah, okay. Basically this is the lib, and who can tell me what's wrong with this lib? Anyone? Yeah. Mostly, yes. But the obvious things, JaxRS shouldn't be there. JavaX inject, this is the CPI classes, shouldn't be there. Java assist, especially version 3.15, which has tremendous problem in JDK 7, shouldn't be there. HiSQL.
Conflict with World.
Yeah, HiSQL. Okay, Juice could be there. Wow, it's a bit old if you use a server. I'm not sure, use it, that's not a problem. But there are so many things, GSR stuff, everything that starts with GSR is just bad, shouldn't be there. You look at validation API sources, like, come on. Okay, I know why the build needs that. It's because it's a grid-based build and it's the sources so we can actually build the stuff. Fair enough, but not in the deployment. So what we did is the configuration I showed here is basically this. We're gonna complain if we find anything mail, activation, Java, sys, JGroup, JBoss logging, KLP, Dom4j, JavaX, JUnit validation. This is the current configuration. This is proper runtime configuration. Nothing hiding. Now, people really don't want to believe, yeah, you did something else, hard coded somewhere. It's not. and I'm going to start that. That deployment will fail. We all know that. It will fail for different reasons, but I won't go there. This is the quick start that was done for AS7, and it's not compatible with WildFly at all. But it looked fine to just prove the point. And we can see here that something is complaining. See all the warnings. WildFly LSD, it says jar and the name of the jar. Could cause deployment problems, and it says the same for IP line, Log4j, JavaXJ, JUnit, validation, IP, and so on. I can change the configuration now, so you will believe me that that's actually everything works, and I think it should be a good demo also. I don't know JBoss CLI. It's not really secret what's going on. I can just go subsystem as I did, see, and it has just one entry config is jar blacklist. And what we have here is jars, and what jars are part of this. And I can now change this. Kabir, am I doing it right? It's a list. I always forget the list syntax.
Forget as well.
Ah, damn it.
Go some with square brackets.
Is it?
I'm not sure.
I know that CLI does something. Oh, it actually worked.
We're experts.
We know what we're doing. Yeah, the list tether is a bit funny, but sorry, wrong one. This one we want. See, and now it actually persisted at back as we changed it in the CLI, and now if I just restart the server.
You just reload.
Yeah, I could. Yeah, sorry.
Choices.
Yeah, so many things I could do. But okay, let me do some different. So we'll have a clean log. Basically, this won't find anything now. This SDD deployer won't complain because there is no mail jar part of that. See, it will say it starting silly deployment detector, but it won't complain about anything. It will just tell what the configuration is here, but nothing else. I should probably configure it a bit differently. Let's say AOP. Let's. Oh yeah. I restarted with reload. So.
Thanks.
See, now it started with a different configuration with the AOP, and now it's deploying, and here it's complaining. See, now that it couldn't find there was just AOP because configuration had held it back. So all that was live, so nothing hidden. So basically, that was what I planned to do for now. This is idea of this is to expand it. It's not really hidden. All the code is there. There are many ideas what to do, and probably I'll work a bit more on it. But if anyone else is interested, I'll accept contributions. When it's mature enough, I can make sure it gets to the WildFly distribution itself, under some conditions to be enabled, not for everyone, but so on. But basically that's it. Any questions? Great.